Right, so this is the first video in a little series that I'm putting together about algorithms and different sort of problem solving challenges, and the idea is that it's something that's quite open-ended and that you can sort of maybe take some inspiration from this and then go off and write your own program, and maybe it will give you ideas for problems of your own. So this is my friend Chris, and he's a maths teacher and he loves palindromes. So during the lockdown, which was obviously a long time ago now, he made a series of daily puzzles that he called Corona Conundrums. And this is one of the early ones, and I'll link to it up there, and it was all about palindromes. So when I say palindrome, I mean things like kayak, because you can read that same left to right as you do right to left. Hannah or race car, those are all words that are the same forwards as they are backwards. Madam or level, there's another one. So it could even be a phrase like one or two of Chris's examples there, like he had I prefer pie. Of course, for a computer, we would have to take the spaces out, or else it wouldn't know that it was an identical string. So what makes something a palindrome? Well, it's usually easy for us to see at a glance whether something is the same forwards as it is backwards. Now, we probably aren't going to reverse it in our heads. Maybe that's how your brain works, but for me, I think what I would do is I would look at the first letter and the last letter and say, are they the same? And then I'll probably, if they are, look at the next letters and look at the next letters and do it that way, rather than trying to reverse the word. For some really short words like Bob, you possibly just do it at a glance, so you don't consciously think about it. But if I asked you to write an algorithm that was going to do this, that's probably going to be a lot more difficult. How are we going to do that? Well, the first couple of algorithms, or variations on an algorithm that I'm showing you, is just how you reverse something without using a built-in method to do it. So again, it's easy for me to tell you to write a word backwards. And if you were doing that on pen and paper, you could just do it yourself. But how do we do that algorithmically? How do we break that down? We use a substring. And if you haven't done substrings, I did a sort of introductory video that covered those, just the mechanics of how you do it, because a few of these algorithms that I'm covering are going to use substrings. And you take one letter at a time. And in this variation of the algorithm, you start at the end. So instead of going like from character 0, character 1, character 2, from left to right, you're going to go from the end. So you're going to go like character 4, and then character 3, and then 2. So starting with an empty string, and then I'm going to loop backwards and take the character off the end, and then take another character off the end, and take another character off the end. So I'm going like character 4, 3, 2, 1, and then character 0. And that gives me two strings, and then I'm comparing, does the original match the reverse string? And if it does, then I've got a palindrome. The problem is, if I'm looping backwards, how do you do that? You could use a forward loop and you could subtract, but most programming languages are going to have a way to loop backwards. So that was one way of reversing a string, but there's a kind of variation. It's really the same overall approach to solving the palindrome problem, but it's just a different way of reversing the string. So rather than looping backwards, and you might find that this is an easier one for you to get your head around, doesn't really matter what one you use, because there's not going to be any great computational advantage of one over the other. Instead of taking a letter from the end and looping backwards, going right to left, this is going to go more normally, left to right, but I'm going to take one letter at a time and stick it before the reversed string. So instead of taking a letter and putting that on the end, and then putting the next one on the end, and the next one on the end, building up the string that way, I'm almost kind of building the string backwards, or the other way around. So I'm putting it on the front and then on the front again. So if I do that in a little animation to show you, if I take the letter K, and this is going from the left to right, so I'm not starting at the end this time, I'm starting at the left at the beginning of the string, take the first letter, and then loop through it again and take the next letter and add that on before, and then take the next one and add that on before, and then take the next one and add it on before, and then take the next one and add that on before. So that's going to give me the same result, and I can compare those. I can run an if statement and say, right, does the first string equals the second string? And if it does, yeah, it's a palindrome. I'm going to show you a little bit of code for each algorithm here, how you can compare it. So, two different ways, A and B, for how you could reverse the string. Well, version A needs to loop backwards. So instead of going like 0 to 10 or 0 to 4 or however long your string is, right, 0 to the length of the string, I've just picked a number to make it easy here. Instead of doing that, we go 10 to 0. Programming languages usually support this sort of thing, and they'll let you count in different amounts in a loop, and it's called how much you're stepping by. A programming language, most of the time, so something like Python or VB, is going to assume that you're counting in ones. If you're using like Java or C# or something, then in the middle of the code for your loop, you would be able to say how much you're incrementing by. But usually, we're going to implicitly be counting up by ones. In this case, I need to tell Python explicitly that although I'm going from 10 to 0, that I'm counting backwards in negative ones. So adding in a comma and a negative 1 there means that this loop's going to go like 10, 9, 8, 7, 6, 5, 4, 3, 2, 1 and go that way instead. Next line of the algorithm is that we're taking this character and saying, right, that's substring at position I, so it's getting one letter out of it. And then reversed, I'm adding the character onto the end. Right, so that's just equivalent to saying reversed equals reversed plus character. And if you haven't seen that syntax before, plus equals, that's just a shorthand way of saying add something on to the end. Right, works with arithmetic operations as well. Now version B, it might well be easier to implement syntax wise. So version B is what you might call a more normal loop, where you're going 0 to 10 and you're just counting up in ones. We're not doing any special step there. The second line of the algorithm is the same as the first version. So we're getting one character, but then instead of adding that character onto the end, I'm adding it onto the start. So reversed equals character plus whatever the existing reversed value was. So that's always shutting it on the start. And now all you need to do with either of these after you've reversed the string is do a simple if statement. If the original equals the reverse string, then you've got a palindrome. Now here's some challenges or some problems, because the whole point of this series was something sort of open-ended, so rather than getting you to answer a specific question that's going to have like one answer, can you try coding one or both versions of this algorithm and check for some palindromes? When you're debugging, if you want a little hint there, if you're not getting the right answers consistently, try using print statements, and in your loop printing out one letter at a time as you're going backwards, so that you can try and figure out maybe you're looping the wrong number of times, or you're one character out to the left or to the right. And then using these algorithms, what would happen if you check the following palindrome? In other words, why is the one on the left a palindrome and the one on the right isn't? Because to a human eye it is, but to a computer it would be seen differently. Now, if you maybe already know something about like ASCII and Unicode from National 5 and higher, that's probably a relatively easy question to answer. More tricky is, well, how could you sort your program? Now that might be using some sort of input validation. It might be that you could go and look up for your programming language, whether it's Python or something else, what are the string functions and methods that would let you convert between upper and lowercase letters. Right? How could you use that to solve your problem? So you might want to pause the video here before you go on to the next bit. This second algorithm is a totally different way of solving the palindrome problem rather than reversing the string. And this is something that, like, in first year uni when we were doing this and the lecturer pointed it out, and because nobody had ever mentioned this way of solving this kind of problem before, you think, oh, that's great, why did I not think of that myself? This has got what I'm going to call like two pointers, effectively two variables, two positions, and we're going to go from the outside and work our way in and check each pair of letters, do they match? And that's probably more like the way that your brain is going to do it. If you were doing this just in pen and paper, you're going to look at the end letters and then work your way in a bit and check, do the letters still match, and do the letters still match, and do the letters still match. So this algorithm might be said to be a little bit more efficient because we could stop the loop early. We could say, well, actually, do you know what? I've found halfway through it that the letters don't match anymore. There's no point in checking the rest because it couldn't be a palindrome. So how do I do it? Well, if I've got my original string variable there and I've got two positions that I'm going to call left and right, and that's represented by these arrows, and I'm going to just work my way in. I would check, is the character with the substring at position left equal to the one at position right? And if it is, then great, I can keep going. So I can check, what about position left and position right now? Do the characters there match? And they do, so I could keep going. And then I could say, well, do they match? And in this case, because it's an odd numbered length, then I could say, yeah, it's literally pointing at the same letter. You could code this using one loop. My variables here that I've called left and right, if I loop for half the length of the string, so if I've got a string that's 10 characters long, I only need to loop 5 times because I'm looping up to the first half and I'm sort of coming in from the other end at the same time. And if I kept going, if I looked 10 times, then my pointers are going to cross over, and it's kind of pointless by then because we've already checked. Loop for half the length of the string. Then I've got an extra line here that I don't really need, but it's just to make it clear, my left and my right. So I'm saying that left equals I, and I'm just assuming that I is my variable that's the loop counter. Left equals I, and right is the length of the string minus 1 minus I. Length of the string minus 1, it means I'm starting on the right hand side, and then minus I is because we're going to keep moving in, right? I don't just want it always to be the length of the string, because the string is going to be the same length. We're not chopping the characters off. So we're going to come in by more each time. And where I've got the dot dot dot, I would be checking, does the character at position left, using a substring, and I'll post the substring video again, does the character at position left equals the character at position right? If it does, then we can keep going. If not, well, actually, we could stop the loop early. You possibly don't know how to do that yet if you're coming at this from more of a Nat5 and higher point of view. So you could go and look it up for your programming language. How do you terminate a loop early? Right, you might find that called a break. Okay, and there's going to be variations depending on your programming language. How could you end that loop early? You could also use a conditional loop. Keep looping while it's still possible to be a palindrome. But if you find a non-match, you could change the Boolean value to say, no, it's not possible anymore. So in other words, the loop can stop. So some questions or some challenges for this, because the whole point of this kind of series was it's something you can explore. That second algorithm, is that more efficient, depending whether the palindrome has an odd or an even length? So if you've got 7 characters, can you just ignore the middle one, because it's going to match itself? I said that the second algorithm can end the loop early if it finds a non-match. So if you find 2 letters that you know don't match each other, there's no point in checking all the others, because straight away it can't be a palindrome. So can you code that? You might well look up breaks, or you could use a conditional loop, but you could see if you can come up with your own solution for it. And can you come up with your own palindrome tester? Does that give you the same results for the second algorithm as it does for the first algorithm? And then once you've coded that the program works for strings, can you write one that checks for numbers? So in Chris's video, which again I'll put up there, he's got a palindrome problem that's a number. If I generate maybe a random number, right, and it's like 1122332211, that's a palindrome of a number, right? But this algorithm would need us to turn that into a string and then treat it as a string to do substrings. So can you do that in your programming language? Could you generate random numbers? Could you make a sequence of numbers? So loop from one value to another value and test all the possible values in between. Then if you look at Chris's video, which again I'll link to, he's got this story about Bob who drives to his therapist, Dr. Awkward, and the number in his mileage is a palindrome. And Chris has got a problem with, can you solve it and can you find the number? Can you solve that problem in code? And if you can solve that, send it to one of us, because that would be quite cool. He's probably intending people to solve that by pen and paper, but we could solve it by code instead.